calculator in hand. I'm going to try to have my calculator as I go through this. Okay, so just a reminder, as we're doing this, you need to remember a couple of things. Just a refresher, right? So we normally think of a normal curve, okay, and up along the y-axis we would have the frequency, like how often it happens, usually as a percentage. And we know a couple of things. If this is a normally distributed set of data, we have, if this is your average, we have 1, 2, 3, 4 standard deviations to the left, and 1, 2, 3, 4 standard deviations to the right. Okay, so 1 standard deviation, 2 standard deviations, and so forth. And then there are 2, and the sign tells us if we're going left or right. And another thing, so this would be just what would go in under this curve. We know that there's 34% on either side, so 68, right, within. So plus or minus 1 standard deviation represents 68%, right? And then it's 95, and then it's 99.7, and then it's eventually 100, right? So these percentages are still always with us. 2.35 after 2.35, and then it's 0.15 and 0.15. Okay, percent, it's always percent, right? So once we get the percentages, we can determine also how many, right? How many would it be if we were given the number of, whatever, frogs, birds, people, whatever the case may be, bars, boxes, you name it. So we're finding the probability under the curve, okay? If you want to find the percentage between or the percentage that are below or above, you need to use normal CDF, right? And you go low, high, and then you go mean standard deviation, right? And if you get a number here, this will be 0 point something, right? If you multiply it by 100, you get the answer as a percentage, okay? Rounded to 2 decimals. So yes, these percentages that we write down are rounded, they're approximate. Normal CDF is very precise, very exact. Okay, so if we don't have, right, if it's just greater than or less than, then obviously we use a very small number or a very large number, depending on if there is no real limit on one of the either the lower or the upper limit. Then we just put in a big number or a small number if it doesn't give us something in between. Okay, so that's what normal CDF, it gives percentage of data points. I should say between, below, or above. Okay, so it can find between, right? So then you would have a low and a high. If it's below, then you would have no low, really. You just have to come up with a small number. If it's above, then you have to come up with a really big number for your upper. Okay, inverse norm. And you have to show me these entries if I ask you for it, okay? Inverse norm needs the percentage to the left of value, and that has to be as a decimal, comma. So this is the one entry there, which will just be a decimal, right? Mean and standard deviation like this, okay? returns value, and I should say along the x, right? Along x, right? That is the cutoff, right? It will actually give you that value that has this many percentage of items to the left of it. Okay, so always keep this in mind. One thing that I probably forgot to mention here, if you call the z-score, so we can actually have values, right? This could be grams, this could be hours, you name it. Then we also have a z-score, which has the mean as 0, and then it's 1, 2, 3, 4, -1, -2, -3, -4, and it tells us how far from the mean you are. Okay, how many standard deviations in particular from the mean you are located at. And right, the closer to 0, the closer to the mean you will be, right? Right, this would be the lowest price, the highest price, lowest score, highest score, and all, like you have to kind of think of it that way, okay? So reading carefully is the key here, and let's dive in here. Okay, a z-score which cuts off the top 13% of data is, so what would be the z-score that cuts off the top 13? Well, let's do a quick normal curve here. If they're talking about the top 13, right, obviously, if 100% is under the curve, this is 50, right? So top 13, you're definitely somewhere in here. And if this is 13%, right, then this would be 87%. So they're telling you they want this value, they're giving you the top, you need what is below it, okay, to figure out what the z-score would be. And some of you are asking, well, Mr. Dirksen, what about this formula here? Couldn't I just use this one? Z-score is going to be value minus the average, right, over standard deviation, okay? Well, you don't have the average and you don't have the standard deviation, right? So you, in this case, you need to use inverse norm, okay? Inverse norm 0.87, right? You want 0.87 and they're asking for a z-score. And remember, a z-score has the average of 0 and a standard deviation of 1, okay? So you can just go 0, 1 here, and this will give you the z-score that you're looking for. And you have options, right? There's a multiple choice scenario here. So let's go ahead and how do we get that again? Second vars, inverse norm, and we just type in 0.87, 0, 1, and it's 1.13 or 1.12, I guess. I guess the answer key needs to be updated. So this would be the answer you would pick, right? 1.12. Because it's the closest one available to us. And notice that it gave you 0.87, 0.13 there just to throw you off. Okay. Next, determine the range of this data set. And this should be fairly easy. Range is high minus low, right? So you just go 9 minus 1, right? Which is 8. Okay. High minus low is your range, and that's 8 there. So that's 9 minus 1, which is 8. So that's how we got that. That should be easy. Determine the mean of this data set. And so again, you can either type this into L1, right, and just do one variable stats and find all of it, or you can just add it up and divide it by 2, 4, 6, 7, right? Divided by 7. So we can do that. So actually, we can probably just do mental math, right? 4 and 3 is 7, and 2 is 9, 16, 18, 27, 28. So it's 28 divided by 7, which is 4. There's our mean there. Determine the median. Median is the middle value of an arranged set of values. So here again, you can just type that in. Why don't I do that to remind you how to do it? Stat, right? Edit. Whoa, I have a whole bunch of stuff there from the previous test. So I'm just going to clear all of that. There. So it's 3, 4, 2, 7, 2, 9, 1. I go stat, sort A. I want to sort L1. Not that it matters. You don't need to sort, because if you do the one variable stats of L1, that gives you, right, the average is 4, which we already knew, right? And our median is 3. So we can actually answer this. It's 3. If you use your calculator, show me the inputs, right? Show me some work that went with it. So if you get it wrong, it's not completely wrong, right? The standard normal distribution. So a standard normal distribution, the value of the mean is 0. Okay? A standard normal distribution, it's when we're talking z-scores, and it's always 0. Okay? In the middle, the average is 0 for us. 6, the result of a survey of families showed that 95%, that is key to us. 95%, that means that we are within 2 standard deviations to the right and 2 standard deviations to the left. That's 95%, right? It's 4 standard deviations in total, right? 2 on either side of the mean. So 95% of families earn between $23,000 and $95,000. What is the standard deviation of the incomes? This one wasn't done so well on the test, but the standard deviation is high minus low, in this case divided by the number of gaps that are in between. Okay, so you go 95,000 minus 23,000 divided by plus 2 and minus 2. There's actually 4 gaps. Okay, so we divide this by 4. So it's 95,000. You just got to be careful here. 95,000 minus 23,000 divided by 4, and that's 18,000 is your standard deviation in this case. Okay. 7, a student's test results produced a z-score of -1. What percentage of all students scored less than this student? I want to say something here, okay? Some of you on the test, let's say this z-score would have been -1.5. Some of you went here and you're like, oh yeah, I'm just going to add this, and half of 13.5. And the answer is it's wrong, because just because the z-score is in between, this bar is not perfectly, it's not a rectangle, right? So the further you go away from -1, the z-score, it's actually less and less. Like, it's the further you go here, the less of the bar percentage-wise belongs to it. So don't make that mistake of doing that. You need to use your calculators in this particular case. In this, I mean, -1, it's an exact. You can actually add up the bars, but I would still just say use your calculator, right? So if it's in -1, what percentage of the students scored less than the student? So you can go normal, CDF, and less would be -10,000, right? -1, because you want everything less than -1. 0, 1, right? Your mean is 0, your standard deviation is 1. So you can go second, second var, sorry, normal CDF. I'm going to go -10,000 just to make sure it's a small enough number, and 0 and 1. and that's 15. I'm just going to multiply that by 100. That's 15.87%, which is approximately 16. So that would be the closest, right? You just pick the closest one, and away you go. Okay. A student's test results produced a z-score of 2.0. What percentage of all students scored greater than this student? So here you have you don't have a limit at the top, right? Normal CDF, right? You have 2 as your lowest, and then in this case you would do 10,000, something that's significantly bigger, 0, 1. Okay. If you have your normal curve handy, and if you know what we're talking about, you can just use that, because both of these z-scores land exactly on a cutoff, right? They're not somewhere in between. So you could use the normal curve, but I'm just gonna go borrow normal CDF and just rewrite it as 2, 10,000. And remember, if your low had been like 50,000, then obviously you need to make your highest number 1,000,000 or something significantly higher, right? 10,000, 0, 1, delete. So that would be, right, times 100, that'd be 2.27. And this one is the closest, right? If you went by the actual graph, the estimated values, it would have been 2.5. Omit 9, don't worry about that one. If you have anything about polling or anything like that, confidence intervals, don't worry about it. Okay. Number 10, the mean height of grade 1 boys is normally distributed, that's important to us, with a mean of 120, a standard deviation of 5 centimeters. A boy whose height is 130 centimeters would have an equivalent z-score of, okay, we are given everything that we need here. Z-score is the actual height of the boy minus the average divided by a standard deviation. That is 10 divided by 5, so that is a 2, right? 2. So z-score would be 2. 2 standard deviations above the mean. So this boy would be considered tall, quite tall actually, with regards to the rest of the classmates. Because I knew everything, I could just use that to find a z-score. If you find a different way of doing these, if you're looking at me like, Mr. Dirksen, couldn't you have done this? Chances are you are right. Like, there are various different ways of getting there, sometimes using a combination of normal CDF inverse norm. Just be careful to show your work when you do that, okay? All right. Part B, long answers, long/short answers. I hope you're doing all right there. Round to 2 decimals, percentage values to 1 decimal. Don't worry about this. It's always 2 decimals, okay? This is 2007. It's a quite an old test, so I've changed everything since then. 2 archers shoot at their targets 10 times, okay? From each from the same distance away. So in that sense, they're both the same. After shoot, it's basically they're both taking the same test, right? The same test, just in different classes. After shooting, the distance in centimeters from each arrow to the center of the target is recorded. The results are as follows. So Archer M, these are the centimeters away from the center. Archer N, you have different ones here. Calculate the mean and the standard deviation of each data set. Can you go ahead and do that? I will ask you what they are. I'll pause this here, and so you go ahead and so enter, telling the keystrokes, and then for Archer M, I have 40.1, and we know what they're in. It's centimeters. That's very important when it's at. Remember the text messages. You got to make sure you have your units. Is it text messages, right? What is it? And so that's that. And the standard deviation for this particular archer is 14.49 centimeters. We tend to not round these to a whole number, okay? And especially now it's continuous, right? Centimeters, you can have decimals. And then I'm going to do the exact same thing. I'm just going to go stat, calculate one variable stat, and now I'm going to do the same thing for the second archer, which is 49.8 centimeters. And the standard deviation is 29.90 centimeters. Right? Is that what you're getting? I need a couple yeses before I move on. So I didn't. I got 1374 for the standard deviation. Same. For Archer N, are we talking Archer N? No, M. Okay, hold on. Okay, everybody's saying M. Okay, let me check. Stat, calc, 13. Yeah, it's 1374. What was I doing? Yeah. Okay, that's where the keystrokes will come in handy. All right, 1374. Thank you. I did that on purpose to check if you're actually paying attention. I wish I could say that. Okay, here we go. Which character is more consistent, a more consistent shooter? Justify your answer with data and by using statistics terminology. Okay, so basically, if you're consistent, you have a smaller range and you have a smaller standard deviation. If you're inconsistent, you have a greater range and you have a more scattered, widespread data. Okay, so that's what those are the words that I want you to have range in there. I want you to have standard deviation, and I want you to say if it's consistent, if it's grouped or around the mean, or if it's scattered, distant from the mean. Okay, so those are the types of things that I'm looking for. So Archer M, right? More consistent shooter. You can do point form. More consistent, lower standard deviation, lower range, data is clustered around the mean. If you could make if we could make a line plot of this, it would be a little bit closer together. Maybe not as much as you would imagine, but it would be closer compared to the other archer. Okay, so Archer N, higher. I will start with higher SD, inconsistent, right? Higher inconsistent compared to M, right? So higher standard deviation, inconsistent, data is clustered, or widespread, data is further from the mean. So Archer M, it's easier to work with it, right? I don't know if anybody's into target shooting, but right, if you're pretty consistent, but you're just you're just not hitting the mark, all you need to do is just make the adjustments necessary on your scope or on your whatever you use to aim, right? And then boom, you'll get there because all your shots are coming with you, right? They're closer to the mean, the average, which is the goal, right? So keep that in mind. You should be comfortable with that at this point. Which of the following distributions has the greatest standard deviation? Use statistics terminology. Explain why this is so. Okay. Now, This one would be clustered, right, around mean. This one would be widespread, further from mean. Okay, so that you should know that this is clustered, this is widespread, so it'd be further from the mean. Graph A will have, will have a higher standard deviation. Range will be larger, widespread. That's good enough. Graph B, it will have a lower standard deviation. Data is clustered around mean. Data is closer to the mean as well. That's good. Smaller range. All of those should be, it should jive. You shouldn't contradict yourself. The order in which you mention them, it doesn't matter to me, as long as you understand higher SD, standard deviation, means higher, greater range, inconsistent, and so forth. If you wanted to put consistency as well, if you wanted to add that, I would look for at least 2 bullets on each, looking for those keywords, of course, and that would get you the marks you're looking for. Okay, the more the better. Bullets are good. Okay, bullet form, point form, that's fine. I don't think this test has a line plot, but if I can mention something, there was one test we did where I asked you to use the same scale, and I want you to use the same scale, right? So you want to compare them side by side. So whatever, if you start with 5 here, make sure you start with 5 and then use the same scale, okay? Make it fit. Because when you see them, when the values line up and you have the lines one on top of the other, you actually can see clearly how spread one is versus the other, right? Like the differences between their standard deviations and the range and consistency, all of that will be apparent when you do that. Okay. All right. I know. Only a couple more days of me, guys, and then you don't have to put up with me anymore. All right. The mean score on test A. This is the second. There's a couple more pages, so we may not make it through the whole thing, but we'll try our best. The mean score on test A was 71% and a standard deviation of 3. And then there's another test, it could be another student, right? 74% with a standard deviation of 2.5. Annie achieves 80% on both of these tests, right? So scores an 80 in test A, 80 in test B. On which one did she perform better? Explained using statistics terminology. In this particular case, you want to use, when you're comparing 2 students in different classes scoring a certain amount, or when you want to compare you yourself scoring, chemistry, physics, and math, you want to know, well, I scored a 60 in physics, a 70 in chemistry, and a 75 in math. Relatively speaking, which course did I do the best? Because we tend to say, oh, of course I didn't do so well in the course where I scored a 60, right? And that's actually not fair, because a 60 in that particular course, with the difficulty of the test and everything else that went around it, a 60 might actually be a pretty good score, relatively speaking. So it's in relation to everything else. Okay. So what happens here? Let me try another. Let's say I'm gonna be a little fast here. So let's say this is test A. The graph, the normal distribution for test A, it looks like this. It's 71% in the middle, and then it's 1, 2, 3, 4, right? So going up by 3%, that's my standard deviation. It'll be 74, 77, 80, and 83. Okay, just checking if I got that right. Yeah, okay, so then it's 1, 2, 3, 4 to the left. So that would be 68, 65, 62, and that would be 59. Okay, 1, 2, 3, 4. So let's say, Annie, this is test A, right? Like this. And an 80% would put you right here. Okay, right there. And so that's test A. Okay, test B, you scored a 74 on. So pay attention, okay? 74 on. This is test B. This is me trying to explain this one more time. And it's 2.5, right? So 1, 2, 3, 4. 1, 2, 3, 4. I know that every second, so this would be 2.5, and another 2.5 is 5, so that'd be 79. And another 5 would be 84. So I'll just do that quickly. So 2.5, and then it's another 5, so it'd be 69, and then another 5 take away from that, that's 64. In this test, right, if this is your normal distribution, we know the average is 71 is in the middle. Nope, wait, 74, which is right here. I already determined that. So let's say this is test B, and 80% would put you right here. Okay, so you can probably eyeball it and see, like, well, it seems like I'm a little higher here compared to here, right? But to be exact, you want to use what we call, so this is a normal distribution, this is a normal distribution. And what we do is we put them both on the same curve, which is the standard normal distribution. And a standard normal distribution uses z-scores, or as the Germans would say, z-scores, right? I'm just kidding. So we want to find the z-scores for each of these marks, right? And then put them under just the under one curve where we know that the average is 0, and then we have 1, 2, 3, 4, right? 4 standard deviations. So we're just worried about the standard deviations that were away from the mean, and that's going to tell us how you did overall, where you did better, which student did better, right? In their categories. So let's find the z-score for test A. Z-score for test A would be the score, which is 80%. You don't have to convert that because everything is in percent, right? Minus the average divided by 3. Okay, and so that would be 80 minus 71 is 9 divided by 3. Sorry, yeah, that's 9 divided by 3. That's 3 positive. Okay, and the z-score for test B is the actual score. We scored in this case 80 in both, right? Minus the average divided by the standard deviation, which is 2.5%. If everything is percent, you can leave it. So this would be 6 divided by 2.5, right? So it's 6 divided by 2.5 in this case, which is 2.4. So now you compare them, right? Test A, you are right here. Test A. Test B, you're at 2.4 right here. Okay, so that is test B. So the higher you are on the scale, the better you perform, right? So this one Annie performed better in test A because of the higher z-score. And you're probably scared now. It's like, what? Like all of this just for like 3 marks. I mean, 3 marks were involved. You do not, I repeat, you do not have to draw any of these normal curves really, unless you really want to, if you have the time. All you would have had to do here is find the z-scores, to determine that I need to find the z-scores of both, then tell me which one did better and why. It's the z-score that will tell you why. They could have both been negative, like the housing question on the test. They could have both been negative, but it's the one that's higher that is actually, in that case, was the more expensive house, relatively speaking. Okay, which ended up being Winnipeg. All right. All right. So number 4, given the following z-scores, calculate the percent area shaded region under each of the following standard normal distribution curves. Show calculator steps and values used. Okay. So here you have a z-score, right, of 0.7. You want the percentage to the left of it. Okay. So because they're asking for percentages, you use normal CDF, and I'm going to use negative. If you use negative 10 in this case, it's just fine. Because the lowest z-score is -4, right? And then anything way down is just gravy, right? And so I'm going to use this normal CDF, and that will give me a decimal, second vars, and normal CDF, -10.701, and that's times 100. That's 75.80%. None of this trying to figure it out, okay? Like, oh, it's 50 up to here, which is true, and then it's just 0.7 of the 34%. You know, it's like it doesn't work that way. Okay, it doesn't work that way. You have to use normal CDF in that case. Okay, and then they want the z-score here, so we're gonna give them that normal CDF. They're giving me a high and a low, right? So minus 1.5 to 2.5, and it's 0.1 if it's a z-score. I don't have to tell you that. And so I'm going to go borrow that one from up there and then just go and overwrite things. And that gives you, if you multiply that by 100, some of you just shift the decimal, right? And that's 698, so it turns into a 70. So that would be it, right? So we did show the calculator steps. That's all I'm asking when you're using normal CDF. Just do that and you'll be fine. Okay? So how are you doing? Are you ready? Are you in it to win it? Okay. A shipment of eggs is normally distributed with a mean height of 5.2 centimeters and a standard deviation of 0.12. Label. So I actually gave you a curve, right? Some of you do not like the curves, but you actually did pretty good on the graphs, I must say. And so we'll do that, right? So first and foremost, okay, what are we talking about? The mean height. So height in centimeters. Please put that down so you don't lose marks. And so we have 5.20 in the middle. We don't have to put centimeters because we already know that that's in centimeters. So to save some room there. So this is 5.34, 5.46, and this is 5.58. And notice that I only do this one only gives you 3 standard deviations, and so we'll just follow it, right? And this would be 5.08, and then you have 4.10 would be 498, 496, right? And this would be 4.84. Okay. There we go. And so normally we would do another. Why don't we do another one here and here? And so taking away another 0.12 would be 4.72, and adding another would be 5.70. Okay, just to make sure. I don't ask you for z-scores here. So this would be the actual value, and this would be a normal distribution. If we talked about a standard normal distribution, we would introduce the z-scores. Okay, which is easy to do. And we also need the percentages, right? 34, 34, 13 and a half, 13 and a half, 2.35, 2.35. And because it's getting pretty tight here, we're just going to arrow it in there. And that's 0.15%. Okay. So there you have it. That's your graph. And normally, when I ask you to graph, I will ask questions based on the graph you just created. That's the only time where you're like, okay, normal CDF, inverse norm, forget about it. I will just base it on my graph. Unless I happen to not include, like if you don't see these values along the X, you either made a mistake or you actually need to use normal CDF or inverse norm, okay? Using the percentages above, determine the percent of shipment that has the heights indicated greater than 5.32. So anything above it. 5.32. Oh, I made a mistake right off the bat, didn't I? This is 5.32. Nobody stopped me. Okay, it's 0.12. 5.32. This is 5.44. And this is 5.6. And this would be 6.8. 5.68. There you go. So I recognize that I made a mistake because I did not see this number here. So you always got to check, right? Think. Greater than 5.32, you add up these three numbers. So it's 13.5 plus 2.35 plus 0.15. And so this adds up to 2.5. So that's 16%. Okay. Less than 4.96, anything less than here, and it's just 2.5%, like that. Between 4.96 and 5.32, 4.96 is here, 5.32 is there. So it's 68 plus 13.5. And that is 72.5. Nope, sorry. And I need to do my math here, right? 71.5. There we go. 71.5% of shipments have the heights indicated. Now, what if they talked about there are, 2,500 shipments on a given day? How many of those would have the height of 4.96 to 5.32? You would just multiply this as a decimal by the number of cartons or boxes being shipped, okay? Don't worry about this. Omit. Six omit, okay? write it down. Question 6, you omit. Not much that I omitted, but there's a couple things here. How are we doing? 306. Don't fall asleep on me. Okay, a study of a new drug is conducted on a group of patients. So now we're getting into the word problems. Okay, now I need to think. You're alive? Okay, good. That's good. I hope everybody else is too. How about this? Raise your hand if you're listening. Raise your hand, click it. Click. Let me see. It's not, statistics is not the greatest unit ever, but it's actually surprisingly important when you get data. And a lot of you are going to have to take statistics in college or post-secondary. Mark my words, you're gonna sit there, and some of it is going to make sense to you because you will have heard of normal distribution, of z-scores, all of that. You will have heard of it. Okay, so a lot of programs make that a prerequisite, and a lot of students flunk it because they haven't heard it before, so they fail it the first time, they have to take it again, so you're spending money and all of that, right? Like, you don't want to do that. So maybe I might save you some time and money right down the road. Okay, a study of a new drug is conducted on a group of patients. Okay, it was concluded that 68% should ring a bell. Okay, it's not just random. 68% of patients required 12 milligrams to 24 milligrams of the drug due to notice a decrease in pain. Right? Calculate the mean and standard deviation of this distribution. Well, ladies and gentlemen, this tells us, remember the 68, 95, 99 rule. Okay, what is that? Oop, you can't see that. Remember these three numbers? Don't forget them. Okay, if I talk 68% of cases, I'm talking plus or minus 1 standard deviation. That means that there's, right, 2 gaps. Because if you go 1 to the left and 1 to the right, we have 2 gaps between those 2 values that we're going to have, right? And then this would have 4 gaps. This would have 6 gaps. And then obviously 100% would have 8 gaps, right? In between, like I'm looking, you're probably thinking, what? Gaps? Okay. Plus or minus a standard deviation, there's between these 2 values, right? There's 1, 2, there are 2 gaps created. Plus or minus 2 standard deviations, right? Between these 2 values that you would be given, there are 1, 2, 3, 4 gaps. Plus or minus 3, there's 6, and then there's 8. Okay, so you got to keep that in mind. So to calculate the mean and standard deviation, a lot of you left this one blank on the test, right? The mean is just high plus low divided by 2, right? You just take those 2 and divide them by 2. So that's 36 divided by 2, that's 18 milligrams. Okay. The standard deviation is high minus low. So 24 minus, right, high minus low divided by 68% tells me that there are 2 gaps in between these 2 values. If you were to graph this on a normal curve, now we know what the mean is, so we could just move up, but we don't know what the standard deviation is. We don't know what the difference is between one value and the other, right, as we move along a normal curve. So the 2 gaps is what goes in here. So I'm actually scared to do this because you're going to be like, yeah, it's always just divided by 2. No, it's because of this. This could be 2, 4, 6, 8, right? So this would be 24 minus 12, that is 12 divided by 2, that's 6 milligrams. Okay, so now you could actually graph your normal curve, and you've determined that 18 is the mean, and then you go 1, 2, 3, 4, you go up by 6, right? So this would be 24, this would be 30, 36, 42. The same thing here. This would be 12, this would be 6, This would be 0, and then you're actually in the -6 here, which doesn't make sense, but that's just how we're going to go with what we're going to go with. But notice that 12 and 24, which is mentioned here, right, between the two, there are two gaps, right? And that's how we figured out the standard deviation. We just subtract them and then divide it by 2 in this case. All right. So now we have the mean and the standard deviation moving forward. If 200 patients participated in the study, determine the percent and number of patients requiring at least 14.8 milligrams of the drug. So we'll just make note of our values that we now know. Usually, right, oftentimes they just give you this. I started off by you having to calculate that. If 200, so at least 14.8 milligrams of the drug to alleviate the pain. So first you need to go normal CDF. At least means 14.8 or more. That's tomorrow, linear inequalities. So I'm just going to go 10,000, right? 14.8 and just put in a big number, 18.6. So let's go ahead and find out what that is. So the second vars, normal CDF, we're going to go 14.8, comma 10,000. 100 would probably be fine. No, sorry, 18 and then comma 6. You should all try this as I'm doing this, okay? So you get 0.7030, and that keeps going, times 100. I'm just going to answer, and that's 70.31%. That's percentage. But how about the actual number of patients? Patients, we have how many? 200, right? Times, take this value right here, 0.7030. I want you to use all of the decimals, and you have them on your calculator, so you just go up to what you got the first time and just multiply it by, in this case, 200. So you have 140.61, which is approximately 141 patients. There, I do want you to round, okay, to the whole nearest whole number. And so forth. I think I'm gonna just do this real quick, but this would be normal CDF 21.5 to 28.5, right? There's a upper and a lower, and then there's the mean is 18, the standard deviation is 6. And I will quickly type this in. So do not use the normal curve to get your percentages from, right? This that multiplies by 100, you get 23.98%. And then patients, I will use that number, 0.23977 times 200. 47.955, which is approximately 48 patients. Okay. A dosage of 10.8 milligrams or less. So normal CDF, negative 10,000, right? Because you want 10.8, which is the greater or less, but you always have to have the less on the left, right? And so this is 18.6, second vars, normal CDF. And you get 0.1150 times 100 is 11.51%. And then patients would be 0.11506 times 200. 23.01, which is approximately 23 patients. Okay. 316. Okay, I'm looking at my time. I don't want to go over if I don't have to. If Eldon requires a dosage that is, okay, now we're switching gears, just so you know. They could be mixed up. I did bunch them up into finding the percentages and the patients, but now determine the following, but we're still basing everything on the very top, right? If Eldon requires a dosage that is 70% higher than the rest of the patients, what is that dosage? Quick normal curve, just a really small one here. If Eldon requires a dosage that is 70% higher than the rest, if you got a dosage here, if you got a dosage of 18 milligrams, which is our average, right? That's the middle, you would be higher than 50% of patients. But right now you are here, this is Eldon right here, and you're saying that this is 70%, right? That whatever dosage he requires, it puts him 70% over the rest. So they give you the left already. Here you have to use inverse norm, and that's 0.770. Let's put that in. What's my average? Is 18. We're not talking z-score. We want the actual value, so we have to use 18 and 6 as our entries there. Second vars, inverse norm, 0.7, 18, 6, and that is 21.15 milligrams, and that's milligrams, okay? Because you're finding the actual value along the bottom of that normal curve that would put 70% below you, 30% above you, but that's like the cutoff mark at that point. Okay, so you just have to read carefully on this one. Okay, Anna needs a dosage that is 25% lower than most patients. Calculate her dosage. And again, Anna has a dosage that puts, right, that has 25% lower than her. So that's this here. This is Anna, this was Eldon, right? So we still were given the percentage. So that's when you know you have to use inverse norm, 18.6. And I'm actually going to use, I'm just going to copy that one and just go 0.25, 18.6. And that's 13.95 milligrams. It could be score on the test. It could be centimeters, right? Anything, but it will be a value and it will be related to the units that you're dealing with. Calculate Eldon and Anna's z-score. For Eldon, right, z-score, well, his actual dosage required is that the average is 18, standard deviation is 6. Here you probably want to be using your calculator. Just make sure you hit equals and then divide, okay? Or put brackets. So it's 0.525. Because it ends, I'm just going to use all 3 decimals there. For Anna, her actual score was 1395 minus 18, which is the average, divided by 6. And that is negative 0.675, which makes sense, right? Anna is below the average. Just look at her actual dosage requirement. And Eldon is above the average, so it makes sense that his is positive and then hers is negative, right? If Biff has a z-score of 1.2, determine his dosage. What percentage and number of patients need a greater dosage than him? That's a loaded question, by the way. So if he has a z-score of 1.2, what is his dosage? Well, they're giving you the z-score. We know that to get the actual score, we take our standard deviation, we multiply it by, drawing a blank now, standard deviation times the z-score, sorry, I was off there, plus the average. That's the formula that you need to use here. Standard deviation is 6, z is 1.2, and the average is 18. So we're going to find 6 times 1.2, which is 7.2, plus 18, that's 25.2 milligrams, based on the z-score. Because you knew everything else, just figure it out that way. What percentage need a greater dosage than him? Well, we're going to say normal CDF, because we need percentage. We need greater than, right? For 25.2 to 10,000, we're going to go 18 and 6. And I'm going a little fast, but I'm recording all of it. At least I am. Okay. Normal CDF, 25.2, 10,000. Some of you are just listening, which is okay, but you will only learn math by doing math, okay? So you need to figure out a way to do that. So 11.51% would be greater than him. So we kind of did a loop a bit, right? Found the actual dosage he needs, and then we used it in normal CDF to find percentage that would need a dosage greater than him, right? So we needed to do that. If it's less than him, then it would be negative 10,000 to 25.2 and so forth. Last one, folks. And this one I might just talk about more than anything else. For a question like this, folks, listen carefully. Mean and standard deviation, this is a frequency table. You have to find the midpoints, right? Midpoints. So you almost wanna, it could be a table, a vertical table, or in this case it's sideways. When you have an interval like that, you need to find the midpoint, right? So 300 plus 350, that's 650, divided by 2 is 325, okay? 350, so this would be 750, right? We're going up by 50, it seems. So this is 375. In this case, it's easy to see, right? And so it's 425, 475, 525, 575, and then 625. Okay, in this case, so this goes into L1, and the frequency goes into L2. Okay, you have to put them into L1 and L2, but you can't do intervals, so you have to find the midpoints. Yeah, go ahead.